Hello and welcome to today's daily Leetcode challenge. Let's begin today's question. We'll be doing it and then comparing it to other results in Leetcode to see where we can improve our algorithm. So stick around to the end of the video. Okay, question 86, partition list. Given a head of a linked list and a value x, partition it in such that all nodes less than x come before node is greater than or equal to x. You should preserve the original relative order of the nodes in each of the two partitions. Okay, so it seems pretty straightforward. We're given a linked list and we have to partition it, meaning find a separation point to the left of which every node is going to have a value smaller than given x, and to the right of that node, every node is going to have value greater than x. Now, a way to do this would just be to create two linked lists and then join them or link them together. One linked list is going to have values of smaller than x. The other is going to have values greater than x. Let's see if this adds up to what's being asked. Head 1 4 3 2 5 2, and the result is 1 2 2 4 3 5. We're given 3 as the input value, and so in white here you see all the linked list that is of smaller than 3, and to the right you see a linked list of values greater than or equal to 3. And you can see the order is also maintained: 4 3 5 4 3 5 1 2 2. Okay, and with that I'm ready to start writing the linked list. So what will we need? A linked list has a singly linked list is a data structure with a start, and then that head points to the next node, and so on until a node no longer points to anything, so none. In order to do that, therefore, we need, for each of the linked lists, we need two values. We need a start and a tail. So I'm going to say low start, low end is equal to none and none, and high start, high end is equal to none, none. And and now let's have the while loop that's going to traverse the whole linked list, the input, and separate it into either the low or the high. So let's say while current, current is equal to head, while current, and now we have to figure out how to under which condition will we put the node into the left or the low linked list, under which we'll put it into the high, and that's pretty easy. If current dot value is less than x, then we put it into the low, else high. So we're going to pass this for now. How do we put it into the low? Well, there are two scenarios. The low is initialized and the low is not initialized. If the low is not initialized, or let's say if the low is initialized, then we say low start. If low is initialized, then it is already initialized. Then low end is next is equal to current, low end is equal to current. If it's not initialized, then we say that low start is equal to current and low end is equal to current. And we don't set anything to we don't set any nexts. Okay, what now? Similar thing we have to do here. If high start, meaning that high has been initialized, then high end next is equal to current, high end is equal to current. So we're setting the tail, the current tails next to current, and then resetting the tail itself to current. That way high end loses its previous value, but adopts the new value, which is just the next node in the list. And then obviously, yeah, else if it's not yet been initialized, then high start is equal to current, high end is equal to current. Okay, that's it. At this point, we should have two linked lists, one starting with a low start, one starting with a high start. And well, now we have to link them together. So how would we link them together? One more thing, I'm thinking that if we don't reset the last values of current.next, we might run into issues. So let me do this quickly. If low end next equals none, if high end, then high end next equals to none. There we go. So what I did there was, since we have these two linked lists now, the tails of both of those might be pointing somewhere else. For example, the tail of the high end would be pointing to 2 here if I don't reset it, because here I set high end to current being 5, and 5 still points to 2. So actually, if I was to return just this, 5 would be pointing back to one of these two. So that would mess me up. But now that I've reset it, I know that there's no cycles in the final linked list. And let's see if we can figure out how to return this, how to link them together. So I'm thinking that if I have a low, there are scenarios where I might be missing one of these, either a low or a high. But what I really need to do, the one condition that I need to check, if low is missing. Because if low is missing, then I just return high. But if it's not missing, then I set low's end to high start. High start could be none, and return low start. So if low start, doesn't matter which one, then I say low end is equal to high start, and return low start, and else just return high start. Let's see if this works. And it does not. I completely forgot to add here that I'm actually looping going through my array. So while current and then at the end current is equal to current.next ensures that I go through each of the linked nodes in the linked list. Yeah, this should work. And I'm getting an error. The output is 122. I have not set my low end next to high start. That was a mistake. Awesome. Yeah, so this is a pretty easy algorithm. I would say that I guess there's room for improvement. Let's compare what we've done. But in general, this is probably, I don't even know why it's medium. Let's look at some of these better solutions. Okay, so a lot less code, and it looks like they've removed some of the conditions that I've had. Okay, so they're setting nodes start, the head and the tail of the small and the large, they set to list node. And then how come they don't care that, how come they don't care to never set start of the low and the high, the small and the large? Would that be because it's pointing to the same node already? Interesting. So this would increase, just remove the number of comparisons we're making. It seems like they are initially pointing start and end, so head and tail of the low and the high, of the smaller and the larger linked lists to the same node. And then because they're doing that, they're just able to always unconditionally set tail of both of those to the next value, and they don't have to check if the value has been initialized or not. So I'm definitely going to do that. That's a lot easier and removes basically two big if statements. The other thing that I see that's kind of throwing me off is this. Remember how we had two places where we, after the traversal of the linked list, we had to set the tails next to nones, and it seems like here they're able to do that simply by setting a success node, which is like the next node, I would say, in the linked list, and then they're overriding current next for each and every single node that they iterate over. So they don't have to have those two conditions at the end. Well, this might be actually slower because you're setting it a bunch of times rather than just twice. So maybe we'll keep what we have, but definitely this has to be adopted. So, and then finally, let's see what's happening here. Tails next, tail small next is equal to head large next. Head is equal to, okay. I think I got it. Let's modify ours quickly. Hoping that I understood anything well. I'm going to leave these two in. I like that a lot more. But what I am going to do is I'm going to rewrite how I've done these guys. So I have a low start, which is equal to list node, and I have a high start, which is also list node. And then I have a low end, which is equal to low start, and I have a high end, which is equal to high start. That's it. They're now both pointing to the same node. And now, in this scenario, we don't need another else if. We simply say that low end is equal to current. simply say low end is equal to current, and low end is equal to current. That's it. We don't ever need to initialize start, because it's just always there. And then finally, let's say low end next is equal to high start next, head is equal to low start next, return head. See how much faster this is. And yeah, it's faster, not significantly, but yeah, should I try resetting these to make sure that no, I think this is faster because this is a constant number of operations. This is just 2, 1, 2, and there I would be doing that step for each of the nodes. So yeah, I would say that this is probably the most optimized solution, and very clear and straightforward. 2 linked lists, one lower, one higher. Initialize both of them, link them together, and return it. And yeah, with that, thank you for watching. I'll see you later. Please like, subscribe. Goodbye.